Everyone, this is actually a continuation of number 12 in section 5.5. I didn't uh, complete the problem. I didn't realize there was a couple other questions at the end of it. So see my previous video for the explanation for how to calculate A1, A4, A prime 1, and A prime 4. Again, we're given this function a of x defined as the integral from 0 to x of f of t dt, where this is the graph of the function f of x. So a of x is basically accumulating area, right, as we move from left to right. So if I want to find a of 1, like we did right here, the integral from 0 to 1, it's the area of this rectangle, right? Below the curve, above the x-axis, it's a 1 by 2 rectangle, which has an area of 2. All right, so let's go down to the questions that we have in the second part. Find formulas for the area function on the interval from 0 to 2 and on the interval from 2 to 4. So for the interval from 0 to 2, let's just look at the graph. From 0 to 2, what would the area be for any arbitrary value of x? Well, let's just say x is some number between 0 and 2. I don't know, 1 point something, whatever it is. Here's the value of x. Well, it's the accumulation function, so it's going to accumulate the total area of this rectangle here, which the value x is how far from the origin we are, right? X is the length here, and the height is 2, right? So it's a rectangle, base x and height 2, and so that's the area, x times 2 or 2x. So the area function is just 2 times x. Okay. On the interval from 2 to 4, uh, then if x is over here somewhere, let's just say x is right here, a little bit more than 3. Now let's talk about that. So we're going to be talking about all this area under the curve, right? Including everything here up through here. And a couple ways you can think about this. The way I thought about this is I can break up this area into two regions that are two triangles. So let me just draw a dashed line that coincides with this line, right? So here I have a triangle, okay? And what is the base of this triangle? Remember, I'm calling this x now. So the distance from 0 all the way out to here, that's x, right? Because x is whatever it is, 3 point whatever. That's the distance from the origin x. But since this function is uh right, input 3, output 3, input 4, output 4, input x, output x, the height of this is also x, right? So this area here of this region here is a triangle, base x, height x. So the area is 1/2 x times x, or 1/2 x squared. Okay, but that's not all the area. We also have this triangle here, which has a height of 2 and a base of 2. So 1/2 2 times 2 gives me 2. And so the total area would be x, 1/2 x squared plus 2. And that's what I have down here. So 1/2 x times x, that was that bigger triangle that I drew. And then 1/2 2 times 2, that's this leftover triangle. Okay. And so I get 1/2 x squared plus 2. Different ways you could have interpreted this. Again, the area under the curve. You can interpret geometrically. You could look at a rectangle and then maybe a trapezoid or something, or a rectangle and another triangle up here, and you could get the same result. You could also think of the function f of x as being piecewise defined, constant function up to 2, and then a linear function, basically um, f of t equal t, right, from between 2 and 4, and you could integrate that function um, and find the antiderivative and do it that way as well. So there's a couple ways this can be done, but hopefully that makes sense for this one. Okay, sorry that I missed these two questions the first time.